This video is for section 9-10. We'll look at the change of base formula for logarithms and solve some more logarithmic equations. Here are two equations that have powers. X to the 2/3 is equal to 30. This one here is 2/3 to the x is equal to 30. They both can be solved with logarithms. But for the first one, because the letter x is the base, we don't have to use logarithms to solve. Instead, you can raise both sides to a power that is the reciprocal of the power that's already there. That isolates the x, and then take a calculator and type 30 to the 3/2 power. The answer, if you round it, is about 164.3. For the second equation, however, using a logarithm is a way to get at the variable in the exponent. Take the common log of the left side and the common log of the right side. When you take the logarithm of 2/3 to the x, we can use the theorem that says we can take this exponent and move it in front of the logarithm. Do you see how that's going to let us solve for x? Because in the next step, we can use division. Log of 30 divided by the log of 2/3. Type that on the calculator to get an answer for x. And rounding off, the answer is about -8.38. In general, to solve an equation in which the variable is an exponent, take the common logarithm of both members of the equation. Let's do one more example of that. Let's say we want to solve this equation for n, and n is located in the exponent. First step, add 5 to both sides. So we have 3 to the n plus 1 is equal to 27. And now that we have isolated the power portion, we can do logarithm. Take the logarithm of the left side and take the logarithm of the right side. When taking that logarithm, take the exponent and move it in front of the log. Then we can divide by log 3 on both sides to get the n plus 1 alone. Type this in the calculator, then subtract 1, and we'll have the answer for n. And the answer turns out to be 2. In general, to solve an equation that has a logarithm in it, exponentiate both members of the equation. Take a look at this example. It already has a logarithm in it, and to get the variable, we would have to somehow remove the word log. We do that with the inverse process, which is called exponentiating. What is the base of a common log, even though it's not shown in this position? It's base 10. So let's exponentiate the equation using base 10. The word exponentiate means to create an exponential that uses the same base as the base of the logarithm. That cancels away the logarithm, leaving the x plus 2 alone. And on the right side, 10 to the 4th power is 10,000. Now subtract 2 from both sides to get the answer 9,998. This section of the book also contains the change of base formula, which allows you to take a logarithm with a base that's not a 10 and rewrite it as a logarithm that does have base 10, which we call the common logarithm. Let's do an example of that. Rewrite log base 5 of 42 using common logarithms. This will be equal to the log of 42 divided by the log of 5. In the top, this is the argument of our original logarithm. In the bottom, the 5 is the base of our original logarithm. Well, why do you need the change of base formula? The reason is that not all calculators have a button that lets you type in different bases for logarithms. Some calculators, like the ones we have on our desk, only have a common log. So if we want to find a base 4 log, we have to have a way to do that. So let's evaluate the base 4 log of 90. We can take the log of 90 divided by the log of 4. Please type that in your calculator to see what you get. And if you round it off, it's 3.24. So 4 raised to the 3.24 power is close to 90. Let's summarize the lesson. We solved some equations using logarithm, and we solved other equations that had a logarithm in it by using exponentiation. We also looked at the change of base formula for any calculator that doesn't have a special button that lets you do the log of a base that's not a 10.